Hello, everyone, and welcome to MOS Live Virtual Planetarium Exploring Space from the Museum of Science. My name is Janine, and I'll be your moderator today. That means that if you're watching us in the Zoom meeting, I'll be the one watching the Q&A box. So if you have any questions throughout the program, go ahead and throw them into that Q&A box, and I'll relay them to our main educators. We also offer closed captions, so if you'd like to see those, click on the closed caption button at the bottom of your screen and select show subtitles. And if you're watching us on Facebook or YouTube, hello! Unfortunately, I'm unable to see your comments at this time, but we hope that you enjoy the show. With that, let's bring on our main educators.
Hello, everybody. My name is Talia. I use she, her pronouns, and I am going to be your educator today, but I can't do it alone.
Hi, everyone. I'm Katie. My pronouns are she and her, and today I will be providing the visuals as we explore space.
And today, to wrap up our 18 months of doing these live streams for the Virtual Planetarium, today is our final show, for now anyway, and we are finishing up our month of returning to take a look at our solar system, which means today we're looking at we've been looking at a rocky world and a gas giant each week. So today we're talking about the last of the rocky worlds and the last of the gas giants, that is Mars and Neptune. And we're going to start with Mars. Mars is, of course, the fourth planet from the sun, one planet farther out than Earth is, and is the second smallest planet in the solar system. It is, of course, famous for its color. It's got this reddish color that you can see really well here in this this program, which Katie is using, which, by the way, is called NASA's Eyes on the Solar System. It is a free program that you can use yourself if you feel like having your own planetarium on your computer. And it has had, of course, many names throughout history from different cultures, because this is a planet that you can see with your eyes. You don't need binoculars or a telescope to see it. So different cultures all over the world gave it names, and a lot of them had to do with the color, which you can see with your eyes from Earth. Mars is noticeably reddish in the sky. So it's had names relating to fire, to blood, to, in this case, Mars is a god of war, and some cultures just named it red, just the word for red. So the color is extremely distinct. That is, of course, due to all the rust that is in the soil of Mars. There's a lot of iron in the soil, and it has rusted over the eras. I mentioned it is the second smallest planet in the solar system. It's just a little more than half the size of Earth, so pretty small. But it is the planet that probably has the most familiar day, night, and seasonal cycles, the one that is most similar to the Earth. You know, we've been talking about planets, some of them that rotate in 10 hours or even less, others that whose days are longer than their years, ones that whip around the sun and ones that take forever to move around the sun. Mars has sort of day-night cycles and seasonal cycles that we can comprehend pretty easily from our Earth-based reference point. Martian day, is only a little bit longer than Earth's day. It is 24 hours and 39 minutes. So it is almost the same length of day as the Earth, which is pretty convenient for when we're trying to sort of figure out shifts for our operators who are working with our Mars spacecraft. Its axial tilt, the degree to which the planet is tilted, which is what determines how severe its seasons are, is actually also comparable to the Earth. If you've ever seen a globe of the Earth in a classroom, it's usually shown tilted. It's tilted by about 23.5 degrees. It's because Earth is tilted by about 23.5 degrees. This tilt gives us our seasons, and it's a fairly moderate tilt. It's not extremely shallow. It's not extremely, the planet's not all the way over on its side like Uranus is. So we have fairly moderate seasons here on the Earth, and Mars is very similar. Mars has a 25.2 degree tilt, so it's a little bit more than Earth, but it means that it also has a very similar sort of cycle of seasons as Earth does, although just a lot colder and longer. Because Mars is farther from the sun, it takes 668 Earth days for Mars to orbit the sun. That is almost 2 Earth years. It's not quite 2 Earth years. So a Martian year is close to twice what an Earth year is. And being farther from the sun and really not having much of an atmosphere, it is very, very cold because atmospheres are blankets for their planets. We'll talk a little bit about that atmosphere in a moment, but that means that the average surface temperature on Mars is negative 80 degrees Fahrenheit. And again, that's the average. It can get way colder. It can get below negative 200 on the surface of Mars, but it actually can also get pretty warm on the surface of Mars. If you're around the equator in the middle of the day in summertime on Mars, you can actually get, what we would consider to be very pleasant temperatures. And we did once register, our measurements on Mars did once register a temperature of close to 100 degrees Fahrenheit at one place on Mars. And again, that's middle of the day in the middle of summer. It doesn't last, but there are times when certain parts of Mars can be a pleasant temperature. But pleasant temperature or not, of course, we really want to think about someday getting humans to Mars, but there are a lot of challenges they're going to have to overcome. As much as there's a recognizable seasonal cycle and the day length is nice and convenient, the temperature is a big one. Like I said, it can get in places pleasant, but average is negative 80. The gravity is just a little over a third that of the Earth, which means humans on Mars would have to learn how to sort of get around by bouncing around. And that can be done. We've seen astronauts do that on the moon where it's even less gravity. So, but that over time can take a toll on the human body, actually, having so little gravity to work with. We'd also have to deal with the fact that this planet doesn't have much of an atmosphere, has very little air pressure at the surface because the atmosphere is only about 1% as thick as Earth's. That means, and it's mostly carbon dioxide, which we cannot breathe, it is poisonous. And that low air pressure, first of all, is part of the reason that the planet is so cold, because there's no blanket, no atmosphere blanket. And it also means that liquid does not stay liquid on the surface of Mars. It either immediately evaporates or immediately freezes. So even if we brought our own liquid water, let's say we brought it and exposed it to the Martian air, it's going to immediately evaporate or immediately freeze. So that's another thing that any humans who want to go to Mars in the future are going to have to deal with. There's also the fact, one thing that is very different about Mars from the Earth is that it has no magnetosphere. Earth does. Earth has a magnetic field. It's what makes a compass work. It also means that we get things like the northern lights, which is what happens when the solar wind interacts with Earth's magnetic field. The magnetic field mostly shunts all that solar wind around us. It does get some particles in at the poles. It gives us the aurora borealis and the aurora australis. But mostly what that magnetic field is doing is shielding us from the solar wind, which is basically radioactive particles from the sun. Mars doesn't have that, which means anybody on the surface of Mars is going to get exposed to a lot more radiation than they would on the surface of the Earth. And that's something that humans would have to deal with if we ever want to go to Mars, not just for human bodies, which do not do well with radiation, but also materials that we bring. A lot of materials don't hold up well under a barrage of radiation either. So some things to consider if we ever do want to get humans to this planet, which we do. Things like temperature, air pressure, radiation, air content, low gravity. That said, it is probably our best bet if we want to go somewhere and send humans to another planet. Mars is actually the pleasantest place we could probably send them. Now, I mentioned that Mars is smaller than the Earth, and it is. It's, like I said, a little more than half the size, but it has some really ridiculous surface features, which are features that we have on Earth, things like mountains and canyons, but much bigger. Mars may be smaller than the Earth, but it has some extreme surface features. Katie's brought us in over one of them, this thing that looks like a tear in the surface of Mars. This is a canyon. This is Valles Marineris. We sometimes call it the Grand Canyon of Mars. And this canyon is far larger than the Grand Canyon. If you put it on the Earth, it would stretch from Boston to San Francisco. So it is the width of the United States. And of course, our Grand Canyon was slowly carved out of the desert over many eons by the Colorado River. This, we think, tore open in a single very bad day. where pressure from beneath the crust built up, built up, built up, and finally the crust couldn't take it anymore, and it just ripped open and created this massive gash in the surface of Mars, which is Mariner Valley, Valles Marineris, the Grand Canyon of Mars. Now, what could cause pressure to build up beneath the crust like that? Well, volcanoes, basically. Mars was once very, very, very volcanically active. And this particular part of the crust has had a lot of volcanic pressure underneath it. You can see not far from Valles Marineris, 3 sort of circular features right in a row. These are 3 of the biggest volcanoes on Mars. And it's the pressure from them that probably caused the canyon to rip open. But not far from them is the big granddaddy of them all, Olympus Mons, or Mount Olympus, the largest volcano in the solar system. This one is so big that if you could put it on the Earth, it would cover France. And you would need about 3 Mount Everests to stacked on top of each other to equal its height. And what's interesting is that that width to height ratio means you can actually walk up Olympus Mons and you wouldn't even realize you were walking uphill. Even though it's the tallest mountain in the solar system, its slope is so shallow that you could walk up it and not necessarily realize you were walking uphill. So much easier climb than Mount Everest, even if this is a much larger mountain. Now, Mars, of course, has, that's a big thing going up. Mars also has some big things going down. It has some really big craters in its surface, big impact features. It doesn't have much of an atmosphere to protect it. So it does have a lot of impact features, including one of the largest in the solar system. It's a big impact area called Hellas Basin. And like I said, it is one of the largest impact sites in the solar system. However, not the largest. The largest impact site in the solar system is on the moon, the South Pole Aitken Basin. Unless it's not, unless in fact the entire northern hemisphere of Mars is a giant impact basin. If you look at elevation maps of Mars, the whole northern hemisphere is noticeably lower elevation than the southern hemisphere. And there is a theory that that is due to a massive impact, that something, maybe up to about 2/3 the size of the moon, that'd be something like the size of Pluto, came and smacked into Mars very early in its history. And actually most of the northern hemisphere of Mars shows the results of that impact, which could mean that could be actually the largest impact site in the solar system, because it would be the entire hemisphere of a planet. But that's not confirmed. We're not sure if that's why there's this ridiculously noticeable elevation difference between the northern and southern hemispheres. Now, Mars, of course, has changed a lot over time. We've mentioned this a few times if you caught past versions of this live stream. It did once have a magnetosphere. It was once volcanically active. It had a lot more atmosphere. It had liquid water on its surface. The question is, how long was that liquid water there? How long was this nice temperate conditions? How long were they around? There's a couple of theories. One that it was actually a very short amount of time, and one that it was actually a very long amount of time. We don't know. That's why we like to send spacecraft to try and figure that out. And I do want to mention some of those spacecraft, but before we do, because I also want to talk about the moons of Mars. Mars has 2 moons, Phobos and Deimos. They are very tiny, very tiny. Phobos is about 14 miles across. Deimos is about 7.5 miles across. So they are very tiny. Compare that to our moon, which is over 2,000 miles across. And they both orbit very close to their planet and very, very quickly. Deimos orbits in a little over an Earth day or a Mars day. And Phobos actually orbits so quickly that it rises and sets multiple times a day. Now, a fact I learned when I was sort of doing some research for this that I found really interesting is, even though Phobos is so much smaller than our moon, if you looked at Phobos in the sky of Mars, it would look about 1/3 the size of a full moon does to us on Earth. And that's because it's so close to Mars. Like I said, it's orbiting very, very quickly. It's very, very close to Mars. So even though it's small, it looks big in the sky. Now, I mentioned spacecraft. This is the most extensively explored planet in the solar system. We currently have, I say we as in humanity, currently have 4 missions on the surface of Mars. 2 NASA rovers, 1 NASA helicopter, and China's first rover, Zhurong. And there are 8 spacecraft in orbit representing 5 different space agencies, I think. And there's more on the way next year. So Mars is one of the easiest places to get a spacecraft to, and it is a place we are fascinated by. So we have multiple, it's got a whole fleet. We like to say it is a planet entirely populated by robots. And the launch windows for Mars open about once every 2 years when Earth and Mars are in the right positions relative to each other, because of course they're both moving around the sun. And there actually are times where we can't talk to our Martian spacecraft. So if we zoom out right now, we can sort of see that in the inner solar system, Mars and Earth look like they're on the opposite side of the sun. And that's because they just about are. Our spacecraft just came out of this time where we can't actually speak to them. So there's the Earth. You can see there, the sun is no longer right between the two, but it was just on Thursday that we regained communication with our Martian spacecraft. There are a couple weeks every year where the sun is in the way and we can't talk to them. Now, before we move on to our gas giant, Janine, have any questions about Mars come in that I should try and answer?
Yeah, we have one question from Laura, who is wondering when that they can observe Mars. Like, so what time of day or year?
Well, right now, because Mars is almost exactly opposite the sun from us, it's up at the same time as the sun, which means it's up during the day. So this is not a time for going and observing Mars. But if we wait long enough, again, both Mars and Earth are moving, Mars will appear in either the early morning or the evening sky. And that's not a constant. It's not like Mars is always a morning planet or always an evening planet. It depends on what side of the sun it's on compared to Earth. So over time, that does change. So I recommend checking to see when Mars is going to be next visible in your area and what time of night. But it will be a while because it's still very close to the sun in the sky right now.
Yeah, I can't see anything against that bright, bright sun. And then Regina would love to know if the possible planetary impact might be an explanation for how and why Mars lost its atmosphere.
We think Mars lost its atmosphere. It actually could have played a role in how Mars lost its atmosphere. A big part of why it lost its atmosphere is because it lost its magnetic field, that shield from the solar wind, which happened because Mars basically cooled down. It is no longer, no longer has erupting volcanoes, for instance. Earth's magnetic field comes from its churning, moving liquid nickel iron outer core, and Mars no longer has that. And losing the magnetic field means the solar wind was able to strip away the atmosphere. However, the impact theory is actually part of why they think Mars lost so much of its atmosphere. Impacts probably played a role.
Okay, I think that's all we have for now.
All right, well then let's head out to Neptune. Last planet in the solar system. Do not come at me, Pluto lovers. I know you're there. Last planet in the solar system, Neptune, last of the gas giants. The smallest of the gas giants. In fact, you can only fit 58 Earths inside of Neptune, which makes it relatively small as gas giants go. It is very far from the sun, 30 times as far from the sun as Earth is, which is about 3 billion miles. And a lot of its vital statistics are very similar to Uranus, which Katie talked about last week. It has a very short day length. It's about 16 hours. It's very, 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 very cold. Average temperature is below -300 degrees. It is very far from the sun, as we said, so it takes a very long time to orbit the sun, about 165 years. Earth years for 1 Neptunian year. And this planet kind of has an interesting history because it is the first time we know that somebody observed it. Galileo saw it in 1612 and 1613. But because its motion in the sky is so slow, unlike like Mars and Venus, which are moving relatively quickly, he thought it was holding still. So he thought it was a star. And since he didn't recognize it as a planet, although he did observe it, we know he did observe it, he doesn't get credit for discovering it. This is the first planet that was actually calculated to exist before it was actually discovered. So in the 1800s, we had discovered Uranus, and a number of astronomers realized that Uranus wasn't moving quite as predicted, and they thought that it might be feeling the gravitational pull of another gas giant farther out that hadn't been discovered yet. So a number of mathematicians worked on this, and astronomers worked on these calculations to figure out, all right, if Uranus is moving this way, how big a planet would we be looking for and where would it be? And there were 2 different men who independently discovered Neptune in 1846 using these calculations, a Frenchman and an Englishman. Now, France and England, traditionally, especially in these eras, did not need a lot of reason to get into an argument with each other, and they argued over this: which of their men had discovered Neptune first? Was it the Frenchman or the Englishman? Ultimately, it was decided they really actually found it at about the same time, and they found it independently. They probably both deserve the credit. So generally, they're both credited with having discovered Neptune. Now, one of the interesting things about Neptune is that the next smallest planet in the solar system after Neptune is Earth. That's a pretty big size gap. And at first, for a long time, we thought, well, maybe you just can't form a planet in that size range. But now, of course, we know of lots of planets in other solar systems, and that is a very common size. It is very common to find planets that are between Neptunes and Earths in size. We call them mini Neptunes. So this is kind of an interesting question. This is one of the most common sizes of planet that we see in the galaxy, but not in our solar system. Our solar system has a huge mass gap between Earth and Neptune. We don't know why. That's a mystery. We're not sure. Now, as with Uranus, the color of the atmosphere is largely due to the methane. There's a lot of methane, in addition to lots of other gases in the atmosphere. There's a lot of methane, though, and methane reflects blue light. So Neptune and Uranus both have a bluish color to them. It is, however, a mystery. We're not sure why Neptune is this nice, very solid blue, and Uranus is more kind of a pale teal color. We don't actually know why that is, but the bluish color that they both have does come from methane. We're not sure why it wound up being 2 different colors of blue. Now, unlike Uranus, when Voyager 2 flew by Neptune, which was in 1989, it noticed a lot of weather patterns. It didn't notice a lot of weather patterns on Uranus. Uranus looked pretty bland when it flew by it. Neptune did have a lot of weather patterns. You can see in this image some white high altitude clouds. It also had a great dark spot. This is a storm that has since vanished. Another smaller one appeared in a different hemisphere, though. So, we know some of the spots on Jupiter are several hundred years old, but we can actually see these huge swirling storms on Neptune appearing and then disappearing, and then new ones appearing to replace it in real time. So there seems to be more variability in Neptune's weather than in Jupiter's. Now, Neptune does have rings. All 4 of the gas giants have rings. Jupiter, Uranus, and Neptune all have pretty pathetic rings when you compare them to Saturn. Neptune's rings are very, very faint, and they are not nearly as stable as Saturn. We can actually see them changing in real time as well. They're just pathetic little things, honestly. They're not much in the way of rings. This planet has 14 known moons. It probably has a whole lot more, and for whatever reason, I find this program does not show you all the moons of Neptune. It does have 14 of them that are known. It probably has a whole lot more because gas giants seem to have at least several dozen moons. But this one only seems to have 14 that we've found so far. Part of that is because it's so far from Earth, it's really hard to find small moons going around outer gas giants from Earth. So it's probably more. The largest one is the moon Triton, and it's large enough that it was discovered only 17 days after Neptune itself was discovered. And it actually orbits backwards. Most moons that formed with their planet will orbit in the same direction the planet spins. Triton does not, which is how we know it is a captured moon. It formed somewhere else and was caught by Neptune's gravity. And we think it's probably from the Kuiper Belt. And I just want to take a little bit of moment before we end here to talk about a little bit what's beyond Neptune, because I just mentioned the Kuiper Belt where we think Triton came from. That is because Neptune is the end of the planets. It's not the end of the solar system. There's a lot more stuff out there. There is the Kuiper Belt, which is kind of like the asteroid belt, but farther out. That's where Pluto lives. And then we've discovered thousands of other Kuiper Belt objects out there, some of which are represented here in this program, like Haumea and Makemake and Arrokoth and Sedna and Eris and all these ones that Katie's highlighting for us. These are all members of the Kuiper Belt. And even farther out from the Kuiper Belt is the Oort cloud, so far out that this program will not show it. But the Oort cloud is the actual outer edge of the solar system, the place where the sun's gravity is no longer in control. But what we do see here in this program are some visitors from the Kuiper Belt, because we get visitors from the Kuiper Belt from time to time in the form of comets. And this program does have several comets whose paths it can show you. And some of those are from the Kuiper Belt, but some of them are from the Oort cloud, the very outermost reaches of the solar system, where the sun looks like just a really bright star, and there's no warmth from it, and its gravity can barely hold on to what's out there. It's so far away, but it is still part of our solar system. And that is the true outer edge. I know we're used to thinking of Neptune as being the edge, but it is in fact the Oort cloud that is the outer edge of our solar system. So Katie's highlighting some comets for us. So that is the end of our final tour of the solar system. Janine, have any more questions come in that I should try and answer?
Well, we do have one question, and I think this is in good faith. So why is Pluto not a planet? Or I would clarify it as, why have we reclassified Pluto's status?
Yes. So one of the cool things about science is that it changes what we call things as we learn more about them, as things no longer fit in the old categories. And it turns out Pluto was never a good fit for a planet. It doesn't look like a planet, for instance. It's out with the outer gas giants. We kind of assumed it was a gas giant when we found it, but it's not. It's this little rocky ice ball about half the size of the United States. So it doesn't look like a planet. Way smaller than even Mercury is. Its orbit doesn't look like a planet orbit. They're pretty flat circles, or close to circles, and Pluto is a very tilted oval. So Pluto doesn't act like a planet. It doesn't look like a planet. It's just that when we found it in 1930, we really didn't have anything better to call it. So we called it a planet because we didn't know about the Kuiper Belt. We didn't start finding other Kuiper Belt objects until the 90s. And once we did, we realized that they were small icy objects in tilted oval orbits out past Neptune, which is exactly what Pluto is. So we stopped calling Pluto a planet and started calling it a Kuiper Belt object, which is what we would have called it from the beginning if we had known about the Kuiper Belt in 1930. So we just put it back into the category it fit properly in. It's still a very cool world, though. We don't care what it's called. It's still an awesome little world.
It reminds me of I think it's on Sesame Street. Which of these things is not like the other?
Yes.
But yeah, and Pluto's got the buddy Charon, and they're like orbiting each other. It's a very, very cool time out in the Kuiper Belt. I don't think we have any other questions here, so I guess that means that it's time for me to turn my video on, and time for you guys for the last time to say goodbye.
Yeah, we really want to take the time to say thank you to all of you who are here today, and those of you who came multiple times and watched a lot of these, we know who you are, and we really, really appreciate. We know you've been here a lot, and we really, really appreciate you taking the time to come hang out with us and let us talk about space to you, because it's like our favorite thing to do.
True, you're all the best. Thank you all so much, and I hope if you're local, you'll come visit us at the planetarium.
Yes, come see us under the dome, where we can really show you what we can do.
You get all the new fancy powers with our recently upgraded planetarium. All right, well, thank you all so much for joining us today. Again, we hope you had fun. We hope you learned something. Thank you for those of you who have joined us many, many times in the past. And we hope that we'll see you one day at the Museum of Science at our planetarium. And you can join us in our home as we've been joining you in yours. Have a wonderful rest of your day. And thank you again.